All right, so this little video is kind of talking about example 6 and the problems that were there. They're a little bit harder, so I did want to do a little video for you. However, before you watch this video, you really can't learn how to simplify trig expressions by watching somebody do it. That's like saying you're going to be an NBA basketball star because you used to watch it on TV all the time. That's not going to happen. The only way for you to become an NBA star is to practice. So if you have not done so, go ahead and pause this video and go away, get your hands messy, try to do these problems, and then come back once you have them and what you think, or if you're stuck, then come back and then you can watch the video and glean my insights from it. But you really, really have to practice and think about these as you go. All right, so you pause the video. I'm going to count down from 5 and then just restart it once you've tried all of these problems. 5, 4, 3, 2, 1. Although maybe I could have done pi minus 1, pi minus 2. Anyway, come back when you're done. Okay, welcome back. Let's talk about some strategies as we're looking at these to see kind of what you're going to do. You should always look at a problem before you attempt the problem. Don't just blindly rush in. We want to make a plan, a strategy. When you see something like A, the first thing I'm going to notice is that I have 2 terms, and I also see that I happen to have a GCF in this. So one of the strategies that we're going to have is to look for a GCF to see if there's anything you can factor out. Factoring is one of those things that is always kind of important. There's not really any good substitutions to make in this one. It wasn't like over here in C, when I was looking at the form of C, I saw a lot of things where I could make some obvious substitutions. So usually I look for obvious substitutions first, and then maybe I look to see if I can factor it. And then look at B. When I look at B, the minute I see that, I don't have any obvious substitutions, but I do have this idea of, well, what's the opposite of factoring is doing a distribution. So you're looking for algebra things that you can do to help you out. You look for obvious substitutions first. You look to see if you can factor it and GCF it. You're going to look to see if you can multiply it out and see what that does for you. You basically have to just kind of get your hands dirty. And sometimes you try something and it doesn't really help you. It becomes more complicated instead of less complicated. And at a certain point, we get an eraser out and we erase it and we start over again. But I'm going to come back here to this first one, and I do want to go ahead and do it by, let's try the factoring. So since there's a sign in both terms, I'm going to pull out, and you can pull out only to the smallest power that you have, and the power there is a 1 and a cube, so you can only pull out a 1. If I take away sine of x, I divide sine cubed by sine, I'm going to be left with sine squared x, and then plus cosine squared x. And let's put our equals in front because we want a transitive format. And right there, we're going to be like, ding, 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 yay. We see something that's going to be really helpful. We recognize, that's why you should memorize these basic identities, that we have a basic Pythagorean identity right here. And so we're going to be able to take that out and now make a substitution. So you evaluate where you're at. You look again to see if there's an obvious substitution at every step. And when I do that, I can do sine of x times 1, and so my final answer is sine of x. Now, I do want to tell you something about this. You can always check your answer. You remember that whole verifying graphically that they were the same? I actually did it for part C, that if I take and just go to Desmos, and I'm going to put in the original problem into Desmos and just graph it. It's fine. We don't care what it looks like. We're not going to be able to graph that by hand, but Desmos can certainly handle it. And so I'm going to graph the left-hand side of the beginning. So graph original problem, or original, let's say, expression. And then what I'm going to do is graph the final expression. And I'm going to see whether or not they are the same. So let's go take a look at it real quick. All right, so here's my graph, and I already typed it in. You can see the whole complicated business that it has. And then I also typed in tangent squared. Now notice right now I'm red. I turn on tangent squared. Oh, look, the blue and the red lie right across from each other when you're looking at it. Red, blue. They appear to be the same. So that means that I'm pretty confident in my answer for that. Now we could do the same thing for the one that we started with, which was, let me look at it again, sine cubed x plus sine x cosine squared. So we can type that in. I'm going to pause so that you don't have to watch me typing it in and then come back. All right, so coming back in, here I've typed it in. Now notice something here that I actually had to type it in as sine of x cubed with parentheses on that. Desmos only allows you to put a square in the location like I've done here and down here for the cosine squared x. They do not recognize when the power is higher than a square. So you do have to, if you're going to do another power, you need to use parentheses and put that in as the parentheses sign of x cubed, understanding what it is. All right, so I'm going to turn that on, and oh, look, doesn't that look like our nice friendly sine of x? And so we do have that correct. All right, so that just gives you a way that you can check your answers as you're going. All right, let's take a look at this B, which should be very obvious because we actually used it over in the part C when I did it. So multiplying it out, secant squared x minus 1, difference of perfect squares, and secant squared x minus 1, Pythagorean identity. This is where you really need to memorize these basic Pythagorean identities so that you can recognize that you have that and that you know that that's equal to tangent squared x. And again, we could verify that by graphing it, but I'm not going to. All right, let's look down here at the bottom and let's see what our options are for this one. Now, you notice, like when I look at D, first I've got a fraction, which we all know we're not fans of. The second thing that I'm looking at is that they both appear to be kind of in the format of those Pythagorean identities. Now, the top one's going to be fairly easy for us. Hopefully, you're going to be like, that's the one that you guys probably know the most. And so I'm going to go ahead and just make that substitution of cosine squared x. So we put that in. Now, cosecant squared x minus 1. So maybe let's scroll back up to where I wrote them down just so that we can talk about them. All these alternate forms. Oh, wait a minute. I didn't write that down. But let's look at the C that we have right here, number 3. We could manipulate that around. You were supposed to do it. One of the options that would be equivalent would be to subtract 1 from both sides and get that that's equal to cotangent squared of x. So that is something that's going to be useful for us down here. So let's scroll back. Sorry, I'm not going back. So that cosecant squared x minus 1 is going to be cotangent squared x. All right, so we're like, all right, we're doing good. We went from addition in the top and the bottom of the fraction to single terms in the top and the bottom fraction. Now at this point, I'm going to say, okay, we've made our substitutions, and just so that we can get clear, the top, the green is matching, and I'll use blue for the bottom, and that was matching. I just did 2 substitutions. You're like, well, there's not a lot I can do here. What am I going to do to try to keep going on this problem? So what we want to realize is that, okay, I do have like quotient identities, reciprocal identities that I can use here. The one that's going to be the obvious, let's just bring the numerator down. And let's make a big fraction bar because we're going to put the denominator. That cotangent, remember, is going to be cosine over sine. And so the reciprocal identity, remember when you have a square, you just square everything. So this is going to be cosine squared x over sine squared x. So I make that substitution in. All right, so I'll go ahead and color it blue since I'm just continuing on. So I basically have done 2 substitutions. I went from this cosecant squared minus 1 and substituted in cotangent squared. And then I went ahead and said, oh, I think it's going to be helpful to make that substitution. Now let's do a little algebra. So we have our cosine squared x times, dividing by a fraction, multiplied by the reciprocal, sine squared x over cosine squared x. And look, right there, we get some cancellation. And our simplified version is going to be sine squared x. Again, you can verify that by graphing. All right, let's take a look at E. Now, E is one of those ones that you're actually going to be able to do this several different ways. And kind of as you're simplifying and as you work with these, one of the things that you'll see is that I don't really care what you do, what order you do it in, as long as you've done legal algebra in every step and legal substitutions. We can take different paths to get there. If we're driving to Carytown from school, I can get on the highway, you can go down Broad Street and cut over, and we can end up in Carytown. It doesn't matter. We can do it 2 different ways. but every step has to be legal. You can't have magic math in there where you use illegal stuff. So one option here that I see when I have two fractions that I'm subtracting, one option might be find a common denominator. So I'm going to go ahead and multiply, and the find a common denominator, this one would need to be multiplied by 1 minus sine x over 1 minus sine x. And then this one would need to be multiplied by cosine x over cosine x, so that we get a nice common denominator. Now, when I do that, and a lot of times when we're doing this common denominator, don't multiply out, don't distribute until you're kind of sure that you want to. That's also kind of a be leery of jumping too fast into doing something. The top is going to be cosine squared x minus. Now I'm going to make a decision here. Do I think I want to multiply this through? We'll do it in the next step if we think so. All right, we're always evaluating what we have, what we want to do here. Now, like, okay, should I distribute? I think I should, but I think something nice is going to happen because I'm looking ahead and I'm thinking about distributing there, and I realize that I'm going to get a plus sine squared and I have a cosine squared. So remember, you're looking for things like the Pythagorean identity. So cosine squared x minus sine x plus sine squared x. I'm going to leave this factored in the bottom. I'm hoping something's going to cancel, and so that's kind of why I'm doing that. The bottom is already factored. The top is not factored because of this big minus right there. So that's why I'm kind of working with the top, trying to get it to simplify. All right, we see that we have a cosine squared plus a sine squared. We're going to remember that that's equal to 1. And right here, we're like, oh, yay, right there, I see that I have a nice cancellation of a common factor. So now I'm down to 1 over cosine x, which is secant of x. And then we can test that out and see how it is. Now, I do, kind of show you a different way to do this. I mean, there's many ways. But like I said, legal algebra and stuff. So I'm going to come over here on the side. I'm going to do the same problem. Let me pause for a second. I'm going to write it down. All right, and this is just to show you that there's many ways to end up in the same spot. Maybe I look at this and over here with this minus sine over cosine, I go, hey, that looks pretty obvious. That's a tangent. I'm just going to make that substitution. And then over here where I have this cosine over 1 minus sine x, there's a trick that we use a lot, which is multiply by the conjugate. And so sometimes we might try to say, hey, let's multiply that by the conjugate. Let's see what happens. In the top, we would have cosine x, 1 plus sine x. In the bottom, we would have 1 minus cosine squared, I'm getting a little ahead of myself there. 1 minus sine squared x. Then I might notice as I'm looking at that, 1 minus sine squared is cosine squared, so that would be cosine x, 1 plus sine x, cosine squared x. Now remember, the rule is you can't substitute and algebra in the same step. So I'm substituting. Now I'm going to cancel this out, so that goes away. And we get to this, and we're like, okay, this is 1 plus sine x over cosine x. Now at that point, we're like, oh, wait a minute. Why did that help me? Don't forget your minus tangent of x. Like, oh, now that I have a single term in the bottom, I can go ahead and split it. You can split fractions when you have a single term in the bottom. Like, oh, this is getting better. So now I have secant of x plus tangent of x. Remember, you got to substitute and do algebra in the next step, and those are going to cancel, and I get secant of x. Now, of course, depending on the way you go, that was obviously way longer than the one that I did originally. So that's, just one of the perils of doing it a different way. Neither is incorrect. They're both correct. One's just shorter. All right, for this last one, I just went ahead and did it so we can make a substitution, show you real quick. I substituted a cofunction identity in. The next thing I did was I substituted an even identity in, or odd identity, sorry. And then I also substituted, my third substitution was a Pythagorean identity, so that became that. Then I did a quotient substitution here. I did a reciprocal substitution. I canceled the negative times negative, and then 1 over sine squared canceled and got cosine beta. So just showing you that I was looking for obvious substitutions in that one. All right, so that will be kind of wrapping up this. Hope you had fun with those. Those are the super challenging ones, and we'll move